Hi, I'm Mr. Kangas, and today we're going to take a look at Chapter 7, Section 5, Slope, and in this video we're going to be taking a look at zero slopes and undefined slopes. There are two types of slope. Now, like we described in the previous video, slope is always in fraction form. You always want it rise over run. Okay. Now, there are two types of line. There are horizontal lines and there are vertical lines that create these special circumstances where you have either a zero slope or an undefined slope. Now, we're going to take a look at the horizontal line first. When you have a horizontal line and you go through and you do your y1 minus y2 over x1 minus x2 to find your slope, you're going to end up with a rise over run where your zero is on top. So the reason why we call this one a zero slope is because 0 divided by 4 is 0. Because 4 goes into 0 times. We know that. It can't go into 0, it goes into it 0 times, so it ends up with a zero slope. That is a horizontal line. That technically counts as a linear function, because you can actually find the slope. Now, the other issue you are going to run into is the vertical line. Vertical lines technically do not count as linear functions. One of the key principles in a linear function is it has to move from left to right forever and ever. And vertical lines do not move left to right at all. Okay. So with a vertical slope, the opposite happens. When you do y1 minus y2 over x1 minus x2, you end up with the 0 on bottom instead of the top. Now, if you try to take 4 and divide it by 0, so in other words, we want to see how many times does 0 go into 4. Well, 0 goes into 4 an infinite amount of times. 0 will never, ever, ever reach 4, no matter how many times you add it. And so that's why we call it an undefined slope. And because we can't define the slope, and because it's not moving, this line is not moving from left to right forever, this technically is not a linear equation. Okay, so in order to be a linear equation, there are a few things that you need. If you're looking at the picture of the linear equation, like I said, it has to be moving from left to right forever and ever. It can't stop. In order for anything to be a function, it can't stop. You can't have a line moving from left to right forever and ever, and then all of a sudden, boom, it goes straight up. Because that represents it's stopped its movement. It's no longer moving forward. It's no longer moving backwards. It just stopped its movement. Okay? That doesn't count. You can't use that. Now, you do have nonlinear functions, which are curves and waves. Okay? Now, they're not heading in a straight line all the time, but they never start going vertical. They never stop their forward or backwards movement. They're always moving forwards and backwards. So that's something you want to look for from a visual perspective. From an equations perspective, we've got something that is going to be coming up in the future sections here. It's called slope-intercept form. This is the standard form for linear functions. And there are a few things that you need to have that you're looking for if you're looking for linear functions. Now, most linear functions, you'll have m and you'll have b. So you might see something like y equals 3x plus 6. Okay? So this is a linear function. There are the three things that you're looking for when it comes to a linear function. First thing, number 1. Okay? There are no exponents on the variables. Or another way to say that, or word that, is you can only, x and y can only have an exponent of 1. We don't write exponents of 1, but every number and every variable has an exponent of 1 unless it's otherwise shown. So if you see a 2 here on the x, then you no longer have a linear function. Your y can't be to anything but the first power either. So, but your 3 You can have an exponent on the 3 or the 6. Numbers can have exponents. Because a number with an exponent is just simply representing a different number. 6 squared is the same thing as writing 36. So I could just easily replace this and write 36. Okay? So that's key thing number 1. The second you put an exponent on a variable, that's when you lose the linear function title and then you move to a non-linear function. Now, those are still functions, but they're not lines. So the second thing a linear function needs, remember these are rules for linear functions, you have to have 2 different variables. So you have to have an x and a y, an a and a b, an m and an n, a p and a q. So as long as you have 2 different variables. And then the third and final thing deals with those variables. The 2 different variables, need to be in separate terms. And the variables need to be in separate terms. So, for example, this is a linear function. It's not written in standard form. I can manipulate it to be in standard form if I would like to. That's something we're going to talk about in the future section. However, it does not prevent me, the fact that it's not in standard form does not prevent me from looking to see if these rules apply. No exponents on the variables. Y has no exponent, x has no exponent. 2 different variables, I have x, I have y. Variables need to be in separate terms. I have 2y, that's one term, and I have 3x, that's one term. The x and y are not in the same term. This is a linear function. Now, if I saw this, okay, this would not be a linear function because x and y are in the same term. Say 2xy is one term, so x and y are in the same term. That is not a linear function. Okay, that's what I mean by separate terms. So even if we didn't have the x here, again, still not a function. X and y are still in the same term. And if you had something that looked like this, where we had 2x plus 3x equals 17, again, not a linear function, we don't have 2 different variables. Or if I had 2x squared plus 3y, not a linear function because I have an exponent attached to my variable. So that's all I got for you on Chapter 7, Section 5. Next section is going to be on slope-intercept form.